Okay, you guys, so for 10.4, this is going to be the area and length in polar coordinates. Okay. This might be a two-part video, this pretty long section. So the first thing we need to do is we need to backtrack a little bit and just talk about some of the calculus we're going to need. So we're going to talk about tangent lines. So we're going to use a formula that you're familiar with, but it looks slightly different. We're going to say that dy dx equals dy d theta divided by dx d theta. So this should feel very similar to parametric curves. When we were doing the derivative of those, we had dx dt or dy dt divided by dx dt. So we're going to do something very similar to this. We know that r is equal to r cosine theta, and we know, x, and we know that y is equal to r sine theta. So these are some of the things we're going to use to help us with calculus. So we can look at a first question. So it says, if r equals 2 cosine theta, find the Cartesian equation of the tangent line when theta equals pi over 3. Okay. So the first thing I'm going to do is I'm going to put everything into x's and everything into y's. So I have x equals r cosine theta. But this means if r is 2 cosine theta, then that means that x is equal to 2 cosine theta times cosine of theta, right? Because this is my r right here is 2 cosine theta. So this would be r times cosine theta. And then let's do y equals r times sine theta. Well, this leads us to 2 y equals 2 cosine theta, which is our r, once again, times sine theta. Okay. So we have this situation for our x and for our y. So now, and actually I can clean this one up if needed. This one is actually what? Sine 2 theta, right? It's the double angle formula for cosine. And this one is actually 2 cosine squared theta. We could clean that up a little and turn it into some version of sine or cosine squared into sine squared, but we're not going to. We're going to leave it like that. Okay, so we have these two formulas. So in order to find the derivative, I'm going to do what I did, similar to parametric equations. I'm going to do dy d theta. So I'm going to do dy d theta is equal to the derivative of sine of 2 theta. So let me do this. Dy d theta, let me do d theta of y equals sine 2 theta. So I'm going to dy both sides. Or I'm sorry, d theta, both sides. Okay, so this should be dy d theta is equal to what? 2 cosine 2 theta. Sure. Right. Sorry, there's a saw in the background and I'm having trouble concentrating. So then we have x is equal to 2 cosine squared theta. So the derivative of sine would be cosine 2 theta times 2. Yep. Okay. So then we have x is equal to 2 cosine squared theta. So then we know if we dd theta both sides, so this would be dx d theta equals 2 times 2 cosine theta times the derivative of cosine theta is sine theta. So then this equals 4 cosine theta sine theta. And I think there's a negative in here. Oh yeah, and this was actually a negative sign right here. So that should be negative 4 cosine theta sine theta, okay? So we have our two derivatives. But remember, if you're trying to find the equation of a tangent line, which is what they asked for, right? They said find the Cartesian equation of the tangent line. So that means that we also need to know a point. So what I'm going to do is they told me when theta is equal to pi thirds. So what I'm going to do is I'm going to come over here and I'm going to say x equals, okay, and then we know that 2 r is equal to 2 times the cosine of theta. So we have to find r first. Okay, so, oops, sorry, x is equal to 2 times the cosine of pi thirds squared, right? Because we said that that's x and we said that is y. So all I did was I plugged pi thirds in, and let's see, the cosine of pi thirds would be what, 1/2, and 1/2 squared is 1/4, and 1/4 times 2 is 1/2, okay? And then y is equal to 2 sine, or sine 2 theta. So this would be sine of 2 theta, but theta is pi over 3. And we know that that would be, let's see here, 2 pi over 3 if we take our unit circle, right? 2 pi thirds. Well, this would be pi thirds, and this would be 2 pi thirds right there. And the sine of that, I believe, is square root 3 over 2. So we get square root 3 over 2. So this is my y, and this is my x. So we have our coordinates, 1/2, comma, square root 3 over 2. So we're going to need this. We're going to need that later. Now, we have to do our dy d theta divided by dx d theta. So dy, all right, we're going to do dy dx is equal to dy d theta, which would be 2 cosine 2 theta divided by dx d theta, which would be negative 4 cosine theta sine theta. And then we're going to use dy dx of pi over 3 is equal to 2 cosine of, what would that be, 2 pi over 3 divided by negative 4 cosine of pi over 3 times sine, times sine of pi over 3. So now take a minute. Let's plug all this in and let's see what we get. When you plug everything in, you should get 1 over the cube root of 3, or the cube root of 3 over 3. I believe that should be correct. Okay, when you guys take a minute to go plug all that in. Cosine of pi thirds is 1/2. So we have 1/2 times square root of 3 over 2 would be square root 3 over 4. So that would become square root 3. And the cosine of 2 pi thirds, I'm just trying to walk through it with you guys right here. The cosine of 2 pi thirds would be, square root 3 over, no, it'd be 1/2 times 2, which is 1. So yeah, we'd end up with 1 over the square root of 3, or square root of 3 over 3. So this is our m, right? So we now have our m. This is my m, and this is my point. And in order to use our point slope form, we know that we're going to use y minus y sub 1, which would be square root 3 over 2 equals m, which is 1 over the square root of 3 times x minus 1/2. Okay, and that would be our Cartesian equation of the line tangent to the polar curve. So This is how you can do it with the derivative. It's just a little bit cumbersome, but hopefully you guys are okay with it. Okay, so now we have to move on. Oops. Now we're going to move on to integration. So here's our formula. You know what? I'll write it in green. Area equals the integral from theta 1 to theta 2 of 1/2 f of theta squared d theta. F of theta squared d theta. Okay, so this is our formula to find the area of a curve. And I want you guys to understand something. The way that it works when you're finding the area is, let's say you have this polar curve, you know, I don't know. Let's just say you have that, something weird like that. And it's a big shape. You know what, I shouldn't even do that. Let's say you have like this big shape, some rose petal or something. The way it works is it sweeps. So when they ask you to find the area in the first loop, it sweeps like this. So it kind of does like this sweeping motion back and forth, you know, and it's really only going one direction, but I'm just showing you guys. It just goes like this, and it sweeps that area right there. Okay, so that's how we're going to calculate our area. Instead of being area under the curve, it's the area swept out from the origin. Okay, so that's why you need your angles or your angular boundaries, your theta 1 and your theta 2, telling you where to start sweeping and where to stop sweeping. Okay, so we have this formula 1/2 f of theta squared. Okay, so we're going to kind of use this on a basic formula. Okay, let me see here. Let's look at find the area of the region bounded by r equals theta, for theta greater than or equal to 0, between theta equals 0 and theta equals 7 pi 4. So in this problem, they gave us the angles where we're looking, and in another problem, they may ask us to find them. So I'm just going to use my formula. First, I want you guys to take out your calculators and graph this using what you learned in 10.3 for polar, or depending on what book you're using, the previous section on polar graphs. So I'm going to go into mode. I'm in polar, and then I'm going to go into y equals, and I'm just going to say theta. Okay, so we're only going from 0 to 7 pi 4. So the graph that I get is something like this, right? And it would keep going, but we're only going to 7 pi 4. So I know that that's going to stop me right there. Ah, geez. Right, so it technically would be this, right? Like that snail shell that you see in all the calculus books and the nautilus shell or whatever. So we're not doing the whole thing, we're only doing this portion of it. And they want to know the area that's swept from here, from 0, all the way up to here, to pi 4. I'm sorry, 7 pi over 4, and that's 0, okay? So we're going to create an integral. So the integral area equals the integral of 1/2 f of theta squared. Well, in this case, f of theta squared, our f of theta is our r. So this would be theta squared d theta. So this would become 1/2 times theta cubed over 3. And we need our angular boundaries from 0 to 7 pi over 4. So then this becomes from 0 to 7 pi over 4. So then we have, let's see here. I guess I could just do 1/2, and then this would be 7 pi cubed over 12, I guess. Or you could do 7 pi over 4. And then I could make this a 1/6 right? So I could just combine these two guys, make that a 1/6, make my life a little bit easier. And then I could just do this guy, cubed minus 0 cubed. Okay, so then that would be what? 7 pi over 4, so 7 cubed, oops, 7 cubed is 343, so 343 pi cubed all over 4, so that'd be 64 times 6, so it'd be 384. Okay, and that would be our final answer, and that's what we would have to work with. Okay, so, and again, if you wanted to do a decimal approximation, you could do 343 times second function pi cubed divided by 384. And we'd get approximately 27.7-ish. That could also be, depending on if they were looking for a decimal, you could use a decimal approximation on this. So this is kind of like the most intro, most basic of all the area formulas. Let's look at another shape. Let's take a circle. So let's suppose we have find the area of let's find the area in the first quadrant of r equals sine theta using polar integration. Okay, so we need to come up with our little integration formula. So we're going to say a equals 1/2. I'm going to put the 1/2 outside of here. You guys can choose to do that. Now, what would be our r equals sine theta? So if you put this in your calculator, you should get this. You should get a circle. Okay, that's as good as it's going to get, guys. I can't draw a circle better than that. That's amazing for me. So we only want the area in the first quadrant. So that means we're going to start here and we're going to sweep, right? And we're going to sweep all the way around. And we only want this area in the first quadrant. So we know that this is what pi halves, and we know this is 0. So we're going to say from 0 to pi over 2. Okay. So that looks good. All right. And then you could, other ones you might have to actually solve. You might have to actually find what theta is to find these zeros. Okay. So what we're going to do is we're going to then integrate f of theta squared. So this is sine squared theta d theta. Oops, I'll write it like this so I don't. So I'm just going to say r equals sine theta. I'm just going to plug it in there and I get sine of theta squared. Now, hopefully you guys are kind of getting the hang of this. This is going to be 1/2 times the integral from 0 to pi over 2 of sine squared theta d theta. But this should be something that you recognize from previous exams. This is actually 1/2 integral of theta to pi over 2 of 1 minus sine 2 theta all over 2. This is how we can reduce the formula from a squared power to a first power. It's a variation, or I don't want to say a derivative in terms of calculus, but it's taken from the half angle formulas. Okay, which are in turn taken from the double angle, which are in turn taken from other stuff. So there's a bunch, or the sum or difference formulas. So there's a lot of ways you can look at this, but these are two formulas, the one to reduce sine squared and the one to take cosine squared, that are going to come up a lot in 10.4. This is kind of the meat of 10.3 and 10.4, is finding in the area swept out by a curve. Okay, so we then are going to make this 1/4 times the integral from 0 to pi over 2 of 1 d theta minus 1/4 the integral from 0 to pi over 2 of sine 2 theta d theta. And you guys hopefully know this is a little u sub, right? 2 theta. So you're going to do this quite often. And you're going to get 2 theta divided by 2 divided by 2. So now we're going to have 1/4. And then this is going to be times theta minus, now this will be what? 1/2 cosine of 2 theta from 0 to pi over 2. So what I did was I factored out these 1/4, put them in front. This 1/2 right here, this 1/2 here is this 1/2 right there. Okay, so then we have 1/4. Now theta is pi over 2 minus 1/2 cosine of pi, which would be -1, I believe. Let's see here. That would be cosine of pi, which is -1. Yeah, sounds good. And then minus 0. So minus 0 minus 1/2 cosine of 0. I'll write this out. I kind of lost myself in there. Okay, so 1/4. Now let's see what we get. Pi halves plus 1/2 plus, oops, this isn't cosine of, this is cosine of 0 plus 1. Let's see, I feel like something went wrong here. So pi halves minus, or 1/2 cosine of pi, and the cosine of pi. Oh, okay. I was wondering what went wrong, guys. Hold on. Okay, I just noticed I did a typo. We got to go way back up here. If I was a video editor, I would edit this part out, but since I'm not a video editor at this point, I wrote the wrong formula. This is cosine of 2 theta. This is the double angle. There is no one for sine, or not the double angle. This is the reduction. So it's both of them have cosine in it. I don't know why I used sine. So this is 1 minus cosine 2 theta over 2. So that's going to change everything right here in terms of values. The calculus and stuff will still be the same, but I kind of screwed that up. Sorry about that, guys. So this is 0 to pi over 2, 1 minus cosine 2 theta d theta. Okay, and this is 1/4. So now we are going to have theta minus sine 2 theta all over 2 from 0 to pi over 2. So then we have 1/4 pi halves. Sorry about this, you guys. I'm just trying to get caught up. Minus the sine of pi over 2 times 2 would be the sine of pi, which is 0, minus 0 minus the sine of 0, which is 0. Okay. So we end up with 1/4 times pi over 2, which is equal to pi over 8. So yeah, sorry about that. I made a silly mistake up here, you guys. Please make sure you go back and correct that in your notes. Hopefully you didn't fall asleep watching the video, so you don't leave that. So we have our final answer of pi 8. So that would be our area under the curve from 0 to pi halves in the first quadrant. So as you can notice, these are taking a little bit of time. These are not short problems. And these are considered like the super easy ones. These are like the nicest ones ever. We haven't even done any of the bad ones yet. So let's look at a bad one, or I guess it's not terrible. So let's find the area enclosed by r equals 1 plus cosine theta in the first and second quadrants. Okay, so if we graph this, we're going to see this shape on our calculator. Okay, so that's as good as it's going to get for me. I'm not even going to mess with that. That's my greatest moment. So we're going to sweep from here to quadrant 1 all the way to quadrant 2. Okay, so we need this area here. And they want it to end at quadrant 2. So that means we're going to go from 0 to pi. That's where quadrant 2 ends. Okay, so what we're going to do now is we're going to take this area and we're going to say 1/2. And remember, I like to just take the 1/2 out, and we're going to go from 0 to pi. of 1 plus cosine theta quantity squared d theta. Okay, so I just plugged my r in and I got r squared. Okay, so for this particular problem, let's see here, where are we at? We're going to have to do another reduction, but we're going to FOIL it out first. So this will be 1 plus 2 cosine theta plus cosine squared theta d theta. Okay. Now we have, that's that, and 1/2, and geez, we're going to have to do a u sub on some of these. Cosine squared, so not a u sub, but a reduction and then a u sub. So this is from 0 to pi of 1 d theta plus 1/2, or we'll say 2 over this, the integral of 0 to pi of cosine theta. Hopefully you guys are seeing what I'm doing. Plus 1/2, and this is now cosine squared theta d theta, right? So I'm going to take this guy and I'm going to clean him up using that same reduction, but this will be 1 plus cosine 2 theta all over 2 d theta. And let's see here. So area equals, what would this be? Theta. So I'm going to do 1/2 integral of pi. I'll just do d theta plus integral cosine theta plus, now this will be 1/4 times the integral of d theta plus 1/4 times the integral of cosine 2 theta. And this is from 0 to pi, from 0 to pi. So hopefully you guys see this is a little bit cumbersome. And this is, like I said, once again, this is one of the nice ones. And then we have area equals, so now, oops, we have 1/2 theta plus sine theta, now that I'm integrating, plus 1/4 theta plus, now this will be a little u sub, right? Oops, 2d theta, so we're going to get that 1/2 again over here, right? So then I'm going to get 1/8 sine 2 theta. Okay, and now all of this is going from 0 to pi. Okay, so let's see, let's clean this up. We can do a little combining. This will be what, 1/2 theta plus 1/4 theta would be 3/4 theta plus sine theta plus 1/8 sine 2 theta from 0 to pi. Hope this is right. Okay, so then we have A equals, and this would be 3 pi over 4 plus, now the sine of pi is 0 plus the sine of 2 pi times 1/8 is 0, right? So that's my f of b minus my f of a. Well, this would be 0 plus 0 plus 0. So then we have a is equal to 3 pi over 4. And I believe that should be correct, yeah. So unless I made a silly mistake in here somewhere with my reductions, that should be okay. And so again, I just want to reiterate to you guys that this is a lot of writing because of all these reductions. I took this guy and just added them. So that's pi over 4. I'm sorry, that's 2 theta over 4 plus 1 theta over 4 is 3 thetas over 4. But theta is worth pi for the f of b, and that's where I got that. And then everything else zeroes out, which is nice. So you're hoping this happens all the time. Otherwise, you're going to have some big, nasty answers. So that's that one. Now let's do one of the cool ones. Let's do a rose petal. Okay. So it says find the area enclosed by one loop. Normally they call this the first petal of R equals 4 sine 3 theta. Okay. So way back in chapter 10.3, I told you, not way back, but the other day, in chapter 10.3, I showed you how to find the angular boundaries for the first loop of a rose. So we're going to fall back to that, okay? So let's look at 10.3. So 10.3 says if you're dealing with sine, you go from, so angular bounds for sine functions are from 0 to pi over n. And for cosine functions, oops, it is negative pi over 2n from pi to pi over 2n. So we're dealing with sine, so we're going to use this guy. We're going to use 0 to pi over n, okay? So let's look at 10.4. So we're going to go, so angular boundaries. We're going to go from 0 is less than or equal to theta is less than or equal to pi over n. And in this case, n is 3. So we're going to go from 0 to pi thirds. Okay. So let's take a look at this guy on our calculator. So I'm going to go y equals, and I'm going to do 4 sine of 3 theta. And I'm going to hit graph. And I get this rose petal like this. And again, you guys, I am not by any stretch of the imagination an artist. This is my masterpiece. This is as good as it's ever going to get. Oh my gosh. Okay, I'll try a little better. Okay, and I guess that's it. I'm not going to get much better than that. Try it one more time. Okay, that's as good as it's going to get. Let me see here. So let's try to make our angular boundaries of 0 to pi thirds. So they want us to sweep in between here. So that's the area swept between 0 and pi thirds. Okay. When I draw it, you guys, I look at the calculator, it looks a little bit better than this, obviously. It kind of does one of these. It kind of swoops out like this. And then this one does the same thing. It kind of swoops out like this. And then this one kind of goes like this. They're all supposed to be symmetric. It's just my drawing is bad, you guys. There are ways to make them not symmetric in a different, if you wanted to mess with everything, but we're going to try to stick to all of our graphs to be symmetric like this. So then our sweeping is right here. Okay. So we have our 0 angle right here. And then we have our pi thirds angle right here. And then all the area in between there. So we're going to take our area function a equals 1/2 integral of r squared or f of theta squared. So this would be 4 sine 3 theta quantity squared d theta. So then let's clean this up. 1/2 times the integral. Oops, I forgot, from 0 to pi over 3. So from 0 to pi over 3, we're going to have 16 sine squared of 3 theta d theta. Okay, so now we're here. So this portion right here, we're looking pretty good. All right, let me see here. I think we can clean up the 16. So this would be area equals 8, integral from 0 to pi over 3. We have sine squared of 3 theta. We know that's 1 minus cosine of double whatever was in there, but what used to be in there, whatever angle that was, we double it. So this is the common mistake, you guys, right here. People forget that this is theta actually, or that's the angle. So when you reduce this, you have to double whatever that angle was. Well, that angle was 3 theta, so now we got to double that. So we actually get 6 theta. That's the common mistake I see students make. So we have area equals, now we can pull that 2 out. So we have 4 integral from 0 to pi thirds of 1 minus cosine 6 theta d theta. So now hopefully you guys are starting to get your u sub really quick. This is u equals 6 theta du. So you don't even have to do this anymore because you can just do it in your head. Hopefully you've been doing so many of them. So now we have area equals 4 times the, oops, we're not going to integrate anymore. We're going to just say 4 times theta minus sine 6 theta over 6 from 0 to pi over 3. Okay, so now we can finalize this. So this is 4 pi over 3 minus, now let's see here. That would be 6 pi over 3. That would be 2 pi, so that's 0, right? Minus 0 minus 0. So we get A equals 4 pi over 3. And that would be our final area, units squared or whatever, okay? So that's how you do a rose petal. The rose petal to me is one of the better ones because the angular boundaries have a set way to find them. You can, the problems don't get completely out of hand like some of the other ones. So it's very doable. So I'd say that the rose petal is a good test question because I consider it like a medium level, and it goes well with other things in the end of this chapter. Okay. Now they could also ask you, remember this was just for the first petal. They could then ask you, what's the area of the whole shape? Well, then you would just say, well, there's 3 of these petals. So you would just triple this and you would get 4 pi. So area of entire rose equals 3 times 4 pi over 3, which is 4 pi. That would be for the entire rose, okay? So let's look at another problem. Okay, so I want to look at an inner loop, and the inner loops are probably the hardest ones. So we're going to say, how about this? Set up the integral needed to find the area enclosed by the inner loop of, and then let's go with r equals 1 plus 2 sine theta. Okay, so take a minute to graph this on your calculator. Again, you always want to have these sketched so you see what you're getting yourself into. Okay, so that's going to be this inner loop right here. Let me graph it again. Okay, so they do something like this. And then it goes like this a little bit. Again, bear with me, guys. The art skill is very lacking. Okay. Yep, that's about as good as it's going to get, guys. So they do one of these. Okay. And again, this is supposed to be symmetric right down the y-axis. I just can't draw. Okay. And they want to know the area of the inner loop. So if you recall from the 10.3 or from the previous section, it talked about in order to find the area of the inner loop, you have to find out when you entered the inner loop and then sweep that area until you come back out of the inner loop. So the way to find that is to set it equal to 0. So we're going to say let r equal 0. So then we have 0 equals 1 plus 2 sine theta. So then we have sine of theta equals what? Negative 1/2. Sine of theta equals negative 1/2. So you want to know when this happens. So when does theta equal negative 1/2? Okay, what angles? So we take out our unit circle, just like we always do. We got our unit circle, and we say, when is sine negative? Well, first of all, sine is negative in quadrant, what do you call it? Quadrant 3 and quadrant 4. That's when our y coordinate is negative. So we know that this happens at 7 pi 6. So this is at 7 pi 6 and 11 pi 6, okay? So this is going to be 7 pi over 6 and 11 pi over 6. So right here, that's 11 pi over 6, and then right here, okay? So that's when we go into the inner loop, right, like this. Right here, we go in at 7 pi 6, and then we come out again at 11 pi 6 at those two angles. Okay, that's the entrance and exit, I guess you could say, or one way to think about it. All right, so now we have to find the area of this guy. So area equals 1/2 times the integral of 1 plus 2 sine theta, d theta, and we got to square this. And we're going to go from 7 pi over 6 to 11 pi over 6. Okay. So area equals 1/2. Now we got to FOIL this out just like always. So this would be 1 plus 4 sine theta plus 4 sine squared theta d theta. So area equals 1/2 times the integral 7 pi over 6, 11 pi over 6. And then we got to do our power reduction. So this is 1 plus 4 sine theta plus 4 times 1 minus cosine 2 theta all over 2 d theta. So we got to keep going. As you can see, these get bad. I think the inner loop for me is one of the worst ones that you run into. So this would be 7 pi over 6, 11 pi over 6 of 1 plus 4 sine theta plus 2, because we can cancel a little bit, plus 2 minus 2 cosine 2 theta d theta. So we can do a little more cleanup. 1/2 integral of 7 pi over 6 to 11 pi over 6 of 3 plus 4 sine theta minus 2 cosine 2 theta d theta. All right, so I think we're getting close to done. So this would be the integral. I think this is, if they ask you to just set up the integral, we would have something like this. Let me see here, so that'd be 2. Yeah, we'd have something like this. Then if if they just ask you to set it up, this would be the answer, I believe. Then if they ask you to integrate but not to calculate, we could say A equals 1/2 times 3 theta plus 4 cosine theta, but then that becomes negative. Minus, now again, we're going to have a 1/2, so this will become 2 over 2 sine of 2 theta from 7 pi over 6 to 11 pi over 6. And then this would be the integration. So we have now integrated, so this could cancel, this would be 1. So our answer that's just ready to integrate, you'd have to go and plug all this in now, and this just gets out of hand. I'm not going to spend time doing it. You guys, I think, can do this. Minus sine 2 theta. If you have trouble with it, let me know, but it's just a big hassle. There's no two ways about it. I try not to give you too many of these in the homework and on the exam, okay? Or maybe I'll just ask you to do the integral, but not to actually substitute in the values, just to find the limits of integration. I think the final answer is supposed to be in my notes. If I did it right, I have pi minus 3 square roots of 3 over 2. It's something really nasty like that. But yeah, that's something we can go over if you guys have trouble with that. Okay, so that would be one of the hardest ones from the first part of chapter 10. Okay, and I think I'm going to end the video on that and then make the second part of chapter 10 with arc length and area between two curves and stuff like that. Okay, you guys? So that'll be it for this one, and I will see you on the next video.